Today we're taking a look at section 1.8, which is titled The Algebra of Functions and Function Composition. I kind of like to just call it New Functions from Old, because this is going to give us several ways that we have of taking some functions and using them as building blocks to build new functions. Okay. So there are two main ways to combine functions to get a new function. The first way is to use our arithmetic operations. Arithmetic. And that, of course, is going to have four sub-methods because there are four arithmetic operations. So I can add, so we're going to be adding functions. I can subtract, so we'll subtract functions. I can multiply, so I can multiply functions. And I can divide. The arithmetic combinations is what we're going to be taking a look at now, but the second big way that we have of combining functions is something called composition, and we'll be taking a look at that in a little bit. Okay, let's just start with some arithmetic. Let's suppose that I had f of x equals x squared, and g of x equals 5 minus x. Okay. These are two separate functions. This is a parabola. This one gives me a line. I could combine those two functions using any of my arithmetic operations. Let's just take a look at addition first. If I wanted to, I could build a new function that I would call f plus g of x. The name of the function is the name of each function, f and g added together. That's one name of one new function that I'm going to evaluate at a point x. It takes a little while to get used to this notation, but that's just one name for this function that I'm going to build. But the way I'm going to evaluate it is actually very simple. I'm just going to take f of x and I'm going to add it to g of x. So if I want to evaluate this function at one point, I'm just going to plug in that point to both functions, evaluate them both, and add the results. So for example, if I wanted to evaluate f plus g at negative 2, that would simply be f at negative 2 plus g at negative 2. I evaluate each function, then I add the results. So let's see, I'm going to put some placeholding parentheses around my x's. So when I'm evaluating f at negative 2, that's just going to give me negative 2 squared, which is 4. When I evaluate g at negative 2, that's going to give me 5 minus a negative 2. Do be careful with that negative. I'm subtracting a negative, so that becomes 5 plus 2. So that would be 4 plus 7. And that's going to equal 11. So I just plug into each function separately and then add the results. And that's pretty much how it works for all of the arithmetic operations. You evaluate them what we call pointwise. Let's write that down. And evaluating pointwise just means you evaluate each function and then do the arithmetic. Okay, so let's go ahead and just write down the names of the new functions that we can build, because some of this is just getting used to the notation. Okay. So we've just said that f plus g of x, I would evaluate as f of x plus g of x. They mean the same thing, but this is the new name if I want to write this as just one function. Okay. Similarly, I could say f minus g of x would just be f of x minus g of x. If I want to multiply, I can write fg of x, and that would mean that I'm evaluating f, evaluating g, and then multiplying the results. So each function gets the same input, but here I'm just indicating that what I've built is one new function whose name is fg. And if I wanted to divide, we'd call the function f over g of x, and that just means f of x over g of x. And of course, anytime I'm dividing, there's a caveat. This is only defined if g of x is not equal to 0. If g of x is 0, that's going to give me something undefined. We won't go there. Okay, so all of these we simply evaluate point-wise. What I'm going to do is just write down some functions. Let's let f of x this time be 1 over x plus 2. Let's let g of x be x squared plus 1 over 2 plus 3x. Let's let h of x equal the square root of x minus 5. So I've given us 3 different functions here. Let's do one together and then I'll give you some to work on. So let's just try a subtraction problem. Let's say I wanted to do g minus h of 6. Okay. So that's saying take this input, plug it into both functions, subtract the results. So that's just going to be g of 6 minus h of 6. So let's see. For g, I'm plugging in x to 2 different locations. So I'm going to get my input squared plus 1 over 2 plus 3 copies of my input, and I'm just plugging in a 6 there. Okay. All right, and I'm subtracting from that h of 6. Well, for h, I'm just subtracting 5 from my input, and then taking the square root. Okay. So if I evaluate this one, let's see. I'm going to get 36 plus 1, so 37 on top. 2 plus 3 times 6 would be 18, so that's going to be over 20, so 37 twentieths. Minus 6 minus 5 is 1. Square root of 1 is just 1, so that's minus 1. And I can simplify that nicely if I just write that 1 as 20 twentieths. So I can say that's, let's see, 37 twentieths minus 20 twentieths would be 17 twentieths. So that would be my answer. All right, so I'm going to put up a few problems for you to try. Again, the basic idea is you just plug in the number to each function and then multiply the results. Yes. So using these 3 functions, f, g, and h that I've given you here, I want you to evaluate f times g of 3. I want you to evaluate h over g of 9. And let's do one more. Let's do f plus g of 3. Okay, so pause the video, try working out these 3 problems, and actually this video has been going for a little while, so just stop the video, work out these 3 problems, and then in the next video we'll go over the answers together.